Hello, hello. If you're watching this, you've made it to the last three videos of Chapter 8, which is exciting. I'm going to try and keep this short. The number of slides is pretty low, but today is definitely when we're going to pick up in the length of some of these problems. So what we're going to get to today is still factoring, but we're going to talk about what happens if there's no GCF, but there's still a number in front of x squared. And if you don't really remember like what that means, we'll take a look at it here in a second. EQ is how can I factor trinomials when there is a coefficient in front of x squared. So we'll get to that in a second. But first, let's review some of the more basic factoring techniques that we've talked about. So if I have three terms, okay, which is often a trinomial, okay, and it's just plain x squared in the front. Remember, factoring, the whole goal is to write it as a distribution problem. I know that in order to get x squared, I'm going to need x multiplied by another x. And then this is where we did the whole find two numbers that multiply to c, but add up to b. Okay, so I need multiplies to 32, but adds up to negative 12. Okay. Now, if it's going to multiply to 32, positive 32, I need two positive numbers or two negatives. And since it's got to add to negative 12, I'm going to need a couple of negative numbers. And remember, this is just guess and check. From here, you try some stuff. Eventually, we get to, if you do negative 8 times negative 4, you'll get positive 32. And if you add negative 8 and negative 4, you'll get negative 12, which means I can say x minus 8 times x minus 4 would multiply or would distribute to be this, okay? So this is what we're looking for when we're talking factoring. And over here, okay, now this is a different technique because there are four terms. The moment you see four terms, your brain should automatically say, I have to factor by grouping, okay? Before I split this up, I want to check, do all four of these numbers have anything in common? And they don't. So I'm going to go ahead and break this up into two groups of two. I'm going to say, all right, what do the first two terms have in common? Well, I can divide by 3, and I can take x squared from both of those, which would leave me with, what's that? 2x plus 3 divided by 3 is 1, x squared, but I take both x, I'm taking both x's out as part of the GCF. So it's just 2x plus 1 in the parentheses. Okay, now I'm ready to move to the second half. 8x plus 4, well, I can divide both those numbers by 4. So this would be 2x and 4 divided by 4 is 1. Remember, when we're factoring by grouping, I need to see this and that be the exact same on the two halves. And as long as they are, I know I've done it correctly. Okay, so then our factors are 2x plus 1, the thing that both sides have in common. And then the GCFs come together to form the other binomial or the other set of parentheses. So 3x squared plus 4. And this is what we're looking for. All right, so we're going to kind of combine these two methods to factor trinomials that have a number in front of x squared. Okay, so what I have listed here on the left-hand side is kind of a step-by-step of what we're going to do. So it's a preview. And it's written on every slide. We're just going to go through 4 examples and be done with this. This process is a little bit longer. It does follow a very specific set of steps. So once you get the hang of it, it'll be the same thing every time. So that's nice. But here's really what happens, okay? If I'm trying to factor 2x squared plus 15x plus 7, I can't do what I did in warm-up problem number 1, where I just go x and x, because when I multiply these together, that's not going to give me 2x squared. It would just give me 1x squared. So there are some other techniques that teachers will show where there's some guessing and checking involved. This method is a little bit lengthier, but it'll work every time. So the first step we're going to do is check for a GCF. Okay. Remember, if I can divide everything by 2, then I don't even have to worry about learning a new technique. But these three terms have nothing in common, so no GCF. Okay. The next thing I'm going to do is I'm going to multiply a and c together. So a is the number in front of x squared, So this is A, with just the number 2. B is the 15 and C is 7. So 2 times 7 is 14. Okay. Now, I'm going to use that new number 14, and I'm going to find two numbers that multiply to 14 and add to B, which is the 15. Okay, so we're still going to make that little like factor tree that we did before, but instead of 7 going on the top, I'm going to put 14 up top. Okay, and this number will always be that times the A value. Okay, so that times that gives you that number. Okay, so I need two numbers that multiply to 14 but add to 15. Well, if it's going to add to 15, remember I can always use the number itself and 1. So 14 and 1 are the numbers that multiply to 14 and add to 15. And this is the piece that is different. This is what makes this technique new. Is what I do with these numbers 14 and 1. Okay, I'm going to change these into a different color just so I can kind of make this pop out at you. So 14 and 1. Now, we all agree that 14 plus 1 is 15, right? You're good with that? 14 plus 1 is the same as 15. So what I'm going to do now is this trinomial that I have right here, instead of plus 15x in the middle, I'm going to put 14x and 1x. So I'm going to split that 15x into two different numbers, 14 and 1. But we all agree 14 and 1 still add up to 15. So 14 plus 1 is the same. I'm going to keep the first and the last term the same. Okay. So what I've done is I've gone from 3 terms into 4 terms intentionally. I am intentionally going to 4 terms so that I can do factor by grouping, which is what the previous video was all about. Okay. That method of factor by grouping only works if there's 4 terms. I started with 3, but I have now intentionally split this up so that there are 4 terms here. The rest of the process is the exact same as what we've been doing. Okay. So what do the first 2 terms have in common? 2 times x, or 2. Both numbers can be divided by 2, and I can take an x from both terms. That would leave me with x plus 7. And over here, 1x plus 7, what do those 2 terms have in common? Nothing. But I can't just put nothing out front. I'm going to put a 1, which if you divide something by 1, everything stays the same. And I know I've done it correctly because x plus 7 is the same on both halves. So our factored version is x plus 7 times 2x plus 1. Okay. So just to kind of recap what we did, we checked for a GCF. We multiplied A times C. We then had to find what multiplies to that AC number that adds to B. And then we replaced B. We replaced the 15x with the 2 numbers that we found in step 3. And then we just did factor by grouping. Okay. Kind of a process. And if that your head's spinning a little bit, that's fine. Repetition will get you there. Okay. So don't feel too overwhelmed right now. So let's look at another example quick. 3x squared plus 8x plus 4. I see a 3 in front, but 3 cannot divide either of those numbers, so I know there is no GCF. I'm now going to multiply A and C together. So I'm going to multiply 3 and 4. So 3 times 4 is 12, and that's the number that goes up top of my factor tree. I need numbers that multiply to 12 but add up to 8. If we start running through what multiplies to 12 pretty quickly, we should come to 6 and 2. Now here is a mistake that I see students make a lot, is they'll just put plus 6 and plus 2 in here. But be careful, because 8 had x with it, I have to put x with both of these numbers as well. Okay, I can't just replace 8x with just the numbers 6 and 2. I'm then going to keep the first term, that A term, and I'm going to keep the last term the same. Now I have 4 terms. Okay, so some students at this point will want to combine these together, but if you combine those terms together, you'll go back right to where we started, and that's not going to help us. Okay, so I'm going to split this down the middle and then focus on the first half. 3x squared plus 6x has a GCF of 3x. If I divide by 3 and take an x away, I'll have 1x plus 2 over here. Then if I do the same thing to the other half, 2x and positive 4, I can divide those both by 2, which would leave me with x plus 2. Okay. Now, here I put the 1 in front of the x. Here I did not. But hopefully by now we feel comfortable that those are saying the same thing. So 1x plus 2, or just x plus 2, times 3x plus 2. And this is our final factored version. Okay. So again, on the left side are just kind of the steps that we will follow every time to do what I call the AC method. And I call it the AC method because that reminds you, oh yeah, I'm multiplying the A number and the C number together. Give it a try. Okay, pause the video. See if you can look at the previous examples and see if you can factor this. Okay. If I check for a GCF here, 4, 8, and 5 have nothing in common. It can't just work for the first 2 numbers. It's got to work for all 3. So there's no GCF here. So I'm going to go ahead and multiply A and C. Now here you do have to be careful because I'm multiplying 4 and negative 5. Okay, so 4 times negative 5 is going to be negative 20. So I need factors of negative 20 that add up to B, which is negative 8. Because it has to add to negative 20, I need one positive number and one negative number. So let's try. If I try 5 and 4, I can't make one of those numbers negative to get 8. So 5 and 4 won't work. If I do 10 and 2, because those multiply to 20, and I make the 10 negative, now, hey, we got negative 8. So again, with those 2 numbers, negative 10 and positive 2, those are what I'm replacing the middle term with here. Okay. 4x squared minus 10x plus 2x minus 5. So keep the last term, keep the first term, and split up the middle term. Okay. Now that I've got 4, we're going to break this into 2 halves. The first 2 terms have 2x as a greatest common factor. And then that would leave me with 2x minus 5 in the parentheses if I divide by 2 and take an x away. And then over here, oh, look at that. I already have 2x minus 5. So my GCF will be 1. And if you want to put a plus in front just to remind yourself. So then my factors are going to be 2x minus 5. And the other one is going to be 2x plus 1. Those GCFs come together. Okay. So here is our factored version of the trinomial. All right, so give one more try just again to kind of, hopefully you worked out some kinks. There are the steps on the side. Okay, give one more try and we'll wrap this up. 2 does not go into 11, so there's no GCF. So we can go right to multiplying 2 and 12. That gives me 24. So I need numbers or factors of 24 that add to negative 11. Because it's positive 24, I need a couple of negative numbers. So negative 6 and negative 4 I could try, but 6 and 4 make 10, not 11. I could try 8 and 3. And sure enough, those do add up to negative 11. So I'm going to replace minus 11x with minus 8x and minus 3x. Now, the order of these does not matter. I didn't mention that earlier, but if you put minus 3 first and minus 8 second, that's totally fine. So 2x squared minus 8x minus 3x plus 12. Now I'm going to go ahead and split this down the middle. First half has a GCF of 2x, leaves me with x minus 4. Second half has a GCF of, let's go orange, negative 3. Don't forget to take out negative 3. Leaves me with x minus 4, which is fantastic because x minus 4 times 2x minus 3 is my answer. Okay. So factoring, again, call it the AC method, but really it comes down to if always check for a GCF first. Okay, just because there's a number in front of x squared doesn't mean you have to do this, and that's what we'll do in the next video. We'll kind of look at the difference between them. But if there is no GCF and there's still a number in front of x squared, then you're going to follow these steps to factor. Yeah.